So now this video discusses about the quadratic expressions, how we can factorize the quadratic expressions, how we can solve the quadratic expressions, and some other concepts behind, including the discriminant and also formulating the quadratic expressions given actual roots. So what is a quadratic expression? Let's say we have two binomial expressions. Let's say have x plus 2, and let's say x minus 5. And let's think of having the product of these two binomial expressions. We'll have x times x, that will be given as x squared. And x times negative 5, we have it as negative 5x. And 2 times x, we have it as 2x. And at 2 times negative 5, we'll have it as the negative 10. And we'll have it as x squared minus 3x minus 10. So what we have obtained is said to be the quadratic expression. So if we say a quadratic expression, the product of two binomial expressions, gives you what you get as the quadratic expression. So a quadratic expression, it is the algebraic expression whose highest degree power is given as actually 2. That is what you get as the quadratic expression. So it is algebraic expression whose highest degree power is given as 2. That is what you get as the quadratic expression. And it carries the general form, which is given as ax squared plus bx and plus c, where a, b, as well as the c, those are the constants. So keep that in mind. And also let's think of generating the quadratic expressions, and from the product of the following. Let's say we have 2x minus 5 times, let's say 1 over 2x plus, let's say 7. So how should you have the quadratic expressions from the product of these two? So 2x times half x, that would be given as, should be x squared. And 2x times factor 7, that is 14x. And negative 5 times half x, that will be given as negative 5 over 2x. And negative 5 times 7, that is should be negative 37. So have negative 37. And in this case, we'll have it as x squared. And these are the like terms we'll think of for simplifying. And we should have to understand that this is the same as having it as over and here. So what you can have is something about, we'll have it as 28x and minus 5 divided by, that is half. That is if we are to use the butterfly method of subtracting or adding fractions, as it is tested. Let's say if we have a over b, minus x over y. This is the same as the diagonally, actually, a butterfly method states that if this is the case, then we should have the product of the diagonal cases, whereby the numerator here should multiply with the denominator here. That will be given as ax, actually ay rather. And we should have minus, that is since we are subtracting the fractions. And denominator here times this, actually numerator will have it as bx, and I divide by the product of the denominators, that is by. And that should be overall divided by the product of the denominators, that is by. Likewise, if we are adding, principle remains the same. So that is what you get as the butterfly method of adding or subtracting fractions, and basically on the simple fractions. So in this case, we'll have it as x squared should be about, it should be x. So x squared and plus 28x minus 5x, that will be given as 23x, and divide by 2 minus 37. So this is what we get as the quadratic expression. And what is the value of a? A is given as, and that should be 1. And what is the b? We have it as 23 divided by 2. And what is the c? We have it as negative 37. So that's how you start to understand about the quadratic expressions. And try to have the following at your own time. And deduce what is a, what is b, and what is c. Let's say if we have m plus 5 and that times 2m minus, let's say, 6. And you should have the product of, let's say, y plus 5 should be 51, and let's say times negative y plus 2. And also let's think of having, let's say, 1 over 2 minus 6 actually x, and it times negative x plus, let's say, 5. So try to have the product of those two actually binomial expressions and see what will be the quadratic expression that will be produced from that. So now let us see how we can factorize the quadratic expressions. And we understand that, let's say, if we have 2x and minus, let's say, 2 in times, let's say, x minus 1. And if we have the product of these two expressions, we'll have the quadratic expression. That will be given as 2x squared. Let's say like that, and that 2x times negative 1, we'll have it as negative 2x. And negative 2 times 6, that is negative 2x. And negative 2 times negative 1, we'll have it as positive 2. That will have it as 2x minus 4x plus 2. Now what you have, this is the quadratic expression. But now what if we are to express from the quadratic expression and back to the product of two binomial expressions? That's now what you get as the, factorizing the quadratic expressions. So that's the point of interest. So how should you have to get back to actually these binomial expressions? So that is what you get as the factorizing the quadratic expressions. So how do you think we should have that one? So in this case, first of all, we look at the value of a, b, as well as the c. So we just have to understand about those values. So what is the value of a? We have it as 2. And what is the value of b? We have it as negative 4. And what is the value of c? We have it as a positive 2. Then we have the product of a as well as the c. So a times c, which is the same as 2 times 2, that is given as, should be 4. And from there we should be thinking of the pair of factors of positive 4, that when we actually multiply will give us a positive 4, but when we add it will give us negative 4. So in this case, a positive 4, this is the same as 1 times 3, it should be 1 times 4. And this is the same as negative 1 times negative 4. This is the same as having it as 2 times 2. This is the same as negative 2 times negative 2. Now on these actually pairs, which pair that when we add will give us negative 4? So the pair is given as this. Therefore we should have to express negative 4x in terms of negative 2, negative 2. So which means for this case, negative 4x, it will be the same as negative 2x, negative 2x. So that's the principle behind it. Now for that case, we'll have it as 2x squared, and minus 2x minus 2x, and plus 2. That will be given as, we'll have to pair up these, we should have to group these terms. We'll have it as, what is the common factor there? We have it as 2x. The 2x into actually 2x squared, we have it as x, and minus 1. And what is the common factor there? We have it as should be 2, negative 2. And negative 2 into that one, we'll have it as x. And actually, negative 2 into positive 2, that is negative 2. Should be negative 1, rather, we'll have it as negative 1. So you may tend to wonder what's going on here. Now for this case, we have negative 2x plus 2. But we should have to ensure that whatever we have here should also be the same as what we should have here. But now, at this point, we have negative 2x and positive 2. So what we should have to express is, we should have to express such that we should have positive here and we should have negative here, so that it should have to match with this expression. So in this case, we should have to understand that having, let's say, a minus b, this is the same as having as a negative a plus b. It is the same as that, and that's the principle that is being used. So in such cases, which means if we have negative 2x plus 2, this is the same as having it as negative 2. This is the same as negative 2, and this is the same as having it as negative 2 and plus, let me just have to use this notation, by the way. Having negative 2x plus 2, this is the same as having it as, negative, and should be 2x and minus 2. It is the same as that. And if we think of distributing the negative, we'll be back to this expression. So in this case, what is the common factor? We have it as actually positive 2. That will be given as x minus 1. So it is the same as that. And which means, even let's say if you can have, and that should be, let's say if you can have negative 5m, let's say plus 25. You should have to understand that this is the same as having it as negative 5m minus 25. So that is the same as that. So that's how you should have to understand the principle behind having actually this expression. So now we have to pick one of what we have inside. We have it as x minus 1 and the times, then we should have to pair up what are the outsides. So we have x minus 2. So as you can see, we have obtained the actually expressions as we had them before. So that's how you should have to understand about the factorization or factorizing the quadratic expressions in that case. And let's say, for instance, we have something about, let's say, m squared minus m, let's say minus 12. So how do you think we should have to factorize this? Principle remains the same. We'll have what is the value of a, we have it as 1, and what is b, we have it as negative 1, and what is c, we have it as negative 2. In that way, then now we should have the product of a as well as the c. So what is the product of a and c? That is given as the negative 12. Then we should be thinking of the pairs of factors of negative 12 that when we add will give us negative 1, but when we multiply will give us negative 12. So in that case, we have negative 12, and let's be thinking of the pairs of the factors. So another simplest way is to use the LCM system, where you have your actually 12 somewhere, then a 2 into 12, that is 6, and a 2 into 6, we have 3, and 3 into 3, that is 1. Then we should be using these actual factors and trying to mix them and having them out in order to obtain what we have at the center, rather to have the value of b. So let's be thinking of, negative 12. This is the same as negative 4. Negative 4, times 3. And in fact, this is the pair that you can choose. So therefore, having negative m, this is the same as having it as negative 4 plus 3. It should be negative 4m plus 3. Negative 4m plus 3m. So that way, so which means we'll have to substitute here with that one. So negative 4m plus 3m minus 12. And from here you can be able to pair up those actually terms. So take note of how we are doing all these things. It also try to have the following. And now let's say if we have something like, let's say 24, let's say x squared and plus 2xy and minus y squared. So how do you think we should have to factorize this? Principle remains the same, and you should have to understand that this is the quadratic expression of x. So what is the value of a? Value of a is given as 24. That is the value of a is given as 24. And what is the value of b? We have it as 2, should be 2y. And what is the value of c? We have it as negative y squared. So that's how you should have to understand it. And in this case, we should have the product of a as well as the c. That will be given as 8 times c, which is the same as 24, and times c, which is negative y squared, which is the same as negative 24y squared in that way. So think of the pair of factors of should be negative 24y squared, that when we add it will give us the value of b, which is more of what we have at the middle. So we can be thinking of having negative 24 should be, we can be thinking of having 2xy being should be about 4 times 6, but let's see how we can mix the factors there, or there should be factors there. So since this is actually since this is positive, then what should have is having 2xy should be the same as 6xy and minus 4xy. That's how you should have it. Therefore have it as 24x squared, and plus, now have to substitute 6xy minus 4xy minus y squared. So in that case, it means we'll have to pair up these and do those. So try to have that on your own. And let's say we have this case as well. Let's say have m squared n squared minus 7mn, and let's say plus 10. So how do you think we should have to factorize this? And our principle remains the same. What is the value of actually a? Value of a is given as should be 1. And what is the value of b? We have it as negative 7, like that. And what is the value of c? We have it as a 10. And we'll try to have that one from there. And now let's be talking about the discriminant. So what is a discriminant? Now if we say the discriminant, this is the expression. This is the expression which is given as b squared minus 4ac, where b, a as well as the c are from the quadratic expression given. That's what we call it as the discriminant. And let's see how we can have the discriminant on the following cases. Let's say if we have x squared and plus 6x, let's say plus 8. what is the value of the discriminant in the following, actually in this expression? So first thing, what is A? It is given as 1. What is B? We have it as 6. And what is C? We have it as 8. And the discriminant is given us in terms of the formula, B squared minus 4AC. And what is the B? We have it as 6 to the power 2 minus 4A1. And what is C8? We have it as 36. And minus, because 1 times 8, that is 8. And 8 times negative 4, that is negative 32. So 36 minus, actually minus 32, that is given as, should be 4. So that is the value of the discriminant. And let's say if we have the quadratic expression, which is given as 2y squared, and let's say minus 22, let's say minus 22, or actually y, and then plus 60. So what is the value of the discriminant and for this expression? So principle remains the same. What is the A? We have it as 2. And what is the B? We have it as negative 22. And what is the C? We have it as 16. In the discriminant formula, we have it as B squared minus 4AC. Then I try to substitute what we can have there. And what if, let's say, we have this kind of a case, and which is given, let's say, x squared minus 9x and plus, let's say, 9. So what is the value of the discriminant in that way? And also we have actually d squared plus 2d, and let's say plus 1 over 4. Determine the value of the discriminant from that one. Let's say if we have 25 p to the power 2 minus, let's say, 70 pq, and let's say plus 49q squared. What is the discriminant? And let's say if we have 16a squared, and a minus 20 should be ab, and plus 25b squared. So what is the value of the discriminant if that is the case? And by the way, we have this kind of a case whereby it is made up of two variables, which is a, b, like that. So how should we have to determine the constants as far as the general form of the quadratic expression is concerned? First of all, as you can see, the first actually a term, it is 16a squared. So which means this expression, it is the expression of a. So if that is the case, the whole of this one, it is a constant part. So by the way, I forgotten to express or emphasize much. You know, quadratic expression has the general form ax squared plus bx plus c. These actually three terms are said to be, the first one is given as is said to be the quadratic part, and the middle one is said to be the linear part, and the final one is said to be the constant part. So these are the components of the quadratic expression you should have to understand. You know, quadratic part, linear part, as well as what you get as the constant part. So those are the components of the quadratic expressions you should have to get in mind about. So that's how you should have to understand about the discriminant. You know, this is the expression given as b squared minus 4ac that you can have. And we're going to look at how essential that particular expression is in course of our discussions. So now let's be talking about the quadratic expressions as perfect squares. So we understand that the perfect square is the number formed when a number multiplies itself twice. That is what we get as the perfect squares. We have, let's say, 4, which is the same as 4 times 4. So 4 is a perfect square. And some other examples that you can have to think about on the perfect squares. So what is a quadratic expression as a perfect square? So if that is the case, then it will be the quadratic expression formed from the product of two similar binomial expressions. Let's say x plus 1 and the times x plus 1. You know this is the same as x plus 1 and to the power 2. It is the same as that. And let's think of actually expanding this. We'll have it as x squared and plus x and plus 1. This is the same as x squared plus 2x and plus 1. What we have is a quadratic expression which is said to be the perfect square. So this is the quadratic expression, and which is said to be the perfect square. And even let's say if we have 2x minus 1 and the times 2x minus 1. So in this case we have it as 4x squared and minus 2x plus 1. That is the same as 4x squared minus 4x and plus 1. So this is the quadratic expression, but it is a perfect square. So take note of that one. So a quadratic expression can be said to be a perfect square basically if it is formed from the two similar binomial expressions. And also try to have the quadratic expressions that are said to be the perfect squares from the product of the following. Let's say 2i minus 2, let's say negative m plus let's say 4, and we should also have let's say negative x minus 4, and let's say we should also have let's say negative q plus let's say 5m, and let's say we should have something about let's say half minus let's say r. So we should have the perfect squares from those actually expressions, if that is the case. Now, given a typical quadratic expression, how can we be able to depict whether the quadratic expression is a perfect square or not? And for instance, let's say if we have x minus 2 and let's say times x minus 2. Let's say that is the case, and that is the same as x squared minus 2x minus 2x plus 4, and that is the same as x squared minus 4x and plus 4. Let's say we have this kind of a case which is a perfect square. How can we be able to determine whether this given expression it is a perfect square or not? And basically we use what we call as the discriminant. So a discriminant for actually, if the quadratic expression is a perfect square, discriminant is said to be 0. Whenever the quadratic expression is said to be the perfect square, the value of the discriminant is given as 0. Let's see how we can have it. So for this expression, what is the value of a? We have it as 1. And what is b? Negative 4. And what is c? We have it as a positive 4. Then let's see what is discriminant. You know, discriminant is given as b squared minus 4ac. And what is b? That is 16. And the 4 times 1, that is 4, and 4 times negative 4, that is 16 as well, which is given as 0. Now since the discriminant is 0, it means this is a perfect square. And let us also see the following cases. Let's say we have x squared. Let's say we have x squared plus 6x plus let's say 8. So determine whether this is this is perfect square or not using the discriminant. So first thing, what is a? We have it as 1. And what is b? We have 6. And what is c? We have it as 8. Then what is the discriminant formula? It's b squared minus 4ac. But now if it is actually a perfect square, discriminant has to be equal to 0. So let's see if it will be that. So b is given as 6, that is 36, like that. And the negative 4 times what is a, we have it as 1, and what is c, we have it as 8. So in this case we have it as 36, and negative 4 times 1 times negative 8, that is negative 36. Should be negative 32 rather, negative 32. So as you can see, discriminant is not equal to 0. So since the discriminant is not equal to 0, therefore this is not the perfect square. And how about, let's say, if we have this case? Let's say if we have something about, let's say, y squared minus 7y and plus 12. So what do you think, whether it is perfect square or not using the discriminant? So if that is the case, we have what is a, that is given as 1, and what is b, we have it as negative 7, and what is c, we have it as 12. So try to determine whether this is discriminant, actually whether this is perfect square or not using the discriminant, like that. And let's say if we have this as well, let's say we have 12 q squared, let's say plus 33 q, let's say minus 9. So determine whether this is perfect square or not using the discriminant. Let's say we have n squared minus 5n minus 14. And also try to do the same. We have, let's say, s squared and plus 3s and minus 7. Try to have that one. And let's say if we have 3x squared and plus 5x plus 2. So try to have that one as well, whether it is perfect square or not, using what we call it as the discriminant. Now let's say if we have the expression which is x squared and plus qx plus 4. Assuming that this is a perfect square, what is the value of q? Now in this case, what is the value of a? We have it as 1. And what is the b? We have it as q. And what is the c? We have it as 4. Now since this is a perfect square, it means the automatically discriminant is equal to 0. So that is given as b squared minus 4ac is given as 0. Hence we substitute and try to solve for q in that way. And what if, let's say, we have the quadratic expression given as m squared minus, let's say, 1 plus q m, let's say, plus 25. Let's say this is actually a perfect square. What is the value of q if that is the case? It also uses the same principle. As it stands here, it means what is the a? We have it as 1. What is b? We have it as 1 plus q. And what is c? We have it as 25. Then since it is perfect square, it means the discriminant is equal to 0. And try to have to substitute that one and solve for the value of q. So take note of that. And now let's be talking about how we can complete the square of the quadratic expression. Let's say if we have the quadratic expression in the general form of ax squared plus bx plus c. You know, in some cases we can have the quadratic expression that contains only the quadratic part and linear part, and we may need to have the constant part. And in some cases we may have the quadratic part and the constant part. We may need of having the linear part. And you know, also in some cases we may have the linear part as well as the constant part. We may need of having the quadratic part. So how do you think we should have to understand about the completing square of the quadratic expression? So if we say completing square of the quadratic expression, the point of interest is that, let's say if we have the quadratic part and the linear part, now we may need of introducing the constant part, but upon introducing that constant part is to make the expression to be the perfect square. Or else we may have the quadratic part and the constant part, where we need to introduce the linear part, specifically the value of b. But upon having that one, we should make the quadratic expression to be the perfect square. That is what we call as the completing square of the quadratic expression. So let's say if we have 2x squared and plus 6x. So what value must be added to make this expression perfect square, or to complete this one, to complete the square? So as you can see here, the value which is missing, it is a constant part. So if that is the case, what is a? We have it as 2. And what is the c? We have it as 6. And what is the c? That's what we are looking for. By the way, b is given as 6 here. And since this expression has to be the perfect square, it means the discriminant is equal to 0. Therefore we have, we have b, which is actually, therefore have b squared minus 4ac is equal to 0. What is b? We have 6, which is 36, minus, what is 4? We have 4 times a, which is given as 8 times c is equal to 0. And from here we can be able to solve for c in that way. So 36 will go this side, and that will be given as, negative 8c is equal to negative 36. Now for this case, c is given as 36 divided by 8. So what is 8 divided by 36? So 8 should be, what is 36 divided by 8? So there is no direct actually division for 36 by 8. Hence, we may think of just simplifying. But anyway, let's just have to leave it the way it is here. But let's think of simplifying that and further. What is common factor? We have 2 into 36. That is given as 2 into 36. That will be, 2 divided by 36. What is that? And 2 divided by 36. That is given as 9. Should be 2 divided by 36 rather. But let's think of using 4. 4 divided by 36, that is, by the way, 36 divided by 4, it is given as 9. And 8 divided by 4, that is given as 2. Hence we have it as 9 over 2. So which means the value that must be added here should be given as 9 over 2. So therefore we have it as 2x squared and plus x plus 9 over 2, like that. What if, let's say, we have something like this? Let's say if we have, should be about, let's say, m squared plus, let's say, 4. What value must be added to make the expression perfect square? So as you can see, what is missing is we have m squared plus, what is missing is it's bm, and we have plus 4. So what is a? We have it as 1. And what is b? That's what we're looking for. And what is c? We have it as 4. So in this case, using the discriminant, we have it as b squared minus 4ac is equal to 0. Then now we have to look for b minus, what is a? We have it as 1. We have it as 4 here is equal to 0. And b squared minus 16 is equal to 0. Then b squared is equal to 16. For this case, we have to introduce the square both sides, and therefore b is given as, should be 4. And by the way, you can have two solutions. Either b is positive 4 or b is negative 4. since we'll have two solutions here, plus or minus. So which means the value that must be added here should be given as -4, should be +4 as or -4, whichever it will be okay. So that's how we complete the square of the quadratic actually expression in that way. And try to have the following at your own time and see what value must be added to make the following expressions as perfect squares in that way. You know, let's say if we can have something about, let's say 2m square, you know, plus, let's say 36, and we have, let's say 4r square, and let's say plus 16, and let's say if we can have something about, let's say half, and a q square, it should be plus, let's say 4q, and I try to have that. Now let's now see how we can solve the quadratic expression actual equations using what we call as the factor method. How can we be able to solve the quadratic equations using the factor method? Now we understand that if we have, let's say, the quadratic expression given as, by the way, what is quadratic equation? So a quadratic equation, this is the quadratic expression with the equal to sign. We understand that the quadratic expression is given as ax squared plus bx plus c. This is the quadratic expression, but now quadratic equation is given as upon having equal to cell here. So this is what we call as the quadratic actually equation, as you can see, and of which we have several methods that have been used to solve the quadratic equations, and one of them is what we call as the factor method, and of which a factor method uses the principle of factorization, in the sense that, let's say if this is the quadratic equation, and we understand that according to the principles behind the factor method, let's say if this is the case, upon being factorized, it is given as x plus, let's say m times, let's say x plus a, actually n is equal to 0. If this is the case, then this factor is equal to 0, this factor is equal to 0. Therefore, we have x plus m is equal to 0, and what is x? We'll have it as negative m. And also using the same principle here, we have x plus n is equal to 0, and x is given as negative n. In all cases, the quadratic equation gives two solutions, and those solutions are said to be the roots. Let's say if we have something like this. Let's say if we have, let's say x squared and minus, let's say x, and let's say minus x is equal to 0. So how should we have to solve for this using the using the factor method? So first thing, we should have to ensure that the equation is in the general form of ax squared plus bx plus c is equal to 0. In all cases, in other words, it should be in the general form of the quadratic equation. As you can see here, it is in the general form. Hence, since we're using the factor method, we just have to look at whether we can factorize that one or not. So as you can see here, it is possible to factorize that one. So we have it as x squared, and minus 2 should be 3x, should be plus 3x, minus 2x should be minus 3x left, minus 3x plus 2x minus 6 is equal to 0. Now in this case we have it as x minus 3 and plus 2x minus 3 is equal to 0. So x minus 3 times x plus 2, which is equal to 0. Then this factor is equal to 0, and also this one is equal to 0. So have x minus 3 is equal to 0, and x is given as 3. and the x plus 2 is equal to 0, and the x will be equal to negative 2. So that is the solution. And also try to look at this case, how we can solve that one. You know, the principle we need to use is, do you know how to factorize? You need to understand it also, and also mastermind much about the factorization, because that's the principles that we are using here. And also, what if we have, let's say, 2x minus, let's say 5 to the power 2, let's say is equal to 9. How should you have to solve for this using what we call it as the factor method, if that is the case? Now principle remains the same, such that we should think of first of all expanding that one. You know, having this case, this is the same as having it as 2x minus 5 times 2x minus 5, which is equal to 0. Then upon expressing that one, we have it as 4x squared and minus 10x minus 10x and plus 25, which is equal to 0. So we have 4x squared minus 20x, and this one should be brought this side. That will be given as 25 minus 9. That will be equal to 0. And take it from here. So make sure you understand about actually how to factorize the quadratic expressions. Otherwise, that is the basis of whatever it is here. And also try to solve the following cases that I just have to get it up. Let's say if we can have to solve the following, and say we have about, let's say, x squared and plus 6x and plus 8 is equal to 0. So for that one, using the factor method, and let's say 4x squared and plus 16x and let's say plus 15 is equal to 0. And also try that one. Let's say 2x squared minus 7x and minus 15. Try to solve for that one as well. And let's say if we have 4x squared and plus 12x and let's say plus 9 is equal, let's say 16 over 9. So how do you think we can solve for that one using the factor method? So first thing, you should be thinking of eliminating the common, should be eliminating the denominator there. So try to have that. Minus, let's say we have negative 6x, 1 minus 6x, plus let's say 9x squared, which is equal to 27 over 9. So should there be any problem? I want to see that one in the comment section below, if there is something which is very difficult. And let us see how we can solve the quadratic equations using what we call as the completing square method. So let's say we have the quadratic equation, which is given as, let's say, x squared and plus 6x and plus 8 is equal to 0. So as you can see it here, this is the quadratic equation, and also which is in its general form. So first of all, we should have to ensure that the value of a is given as 1. So as it is here, really it is 1 here. Otherwise, we could have to divide everything by the value of a which is there if it is other than 1. Then we should have to transfer the constant part to the other side. Hence we'll have it as x squared plus 6x, which is equal to negative 8. But now looking at the left hand side of the equal to sign, you know, the expression is incomplete. What is the value which is missing? We are missing the constant part, which is c. And the constant part which is to be introduced should also be introduced in this point. So in this side as well. So in this case, we should also have to indicate that the c has to be pressed there as well. But this particular value of actually c, it should make the expression to be the perfect square. In other words, we should have to complete the square here. So what did we say? So in this case, we use the discriminant as well. What is a, we have it as 1, and what is b is given as 6. We are looking for the value of c, which is we don't know. So for this case, we have the discriminant b squared minus 4ac is equal to 0, since it has to be perfect square. So b is 6, that is 36 minus, and 4 times 1, and which is 4 times c, which is 4c is equal to 0. And I have negative 4c, which is equal to 36. Should be negative 36. And this will be given as negative 36 divided by negative 4. And 4 into negative 36 should be 4 into 36, that is given as should be 9. Therefore, the value of c that is to be added here should be 9. So we should have it as that. Now have it as x squared plus 6x plus 9 is equal to negative 8 plus 9. That will be given as x squared plus 6x and plus 9, which is equal to, we have it as 1 here. Then we should have to eliminate the middle part, which is linear part, and each sign must be given to the value of the c that has been calculated. So since this is positive, then we'll have this one as positive as well. Hence we'll have it as x squared plus 9 is equal to 1. And from there, we should have to express that c to have the power 2. Hence we'll have it as x squared and plus 3 to the power 2. And by the way, in all cases, this c has to be the perfect square, which is equal to 1. And in that point, we should have it as x plus 3 and to the power 2 is equal to 1. Then we should have to eliminate the power here by introducing square root both sides. That will be given as, something like this. And also this side, but it should be plus or minus here, since we'll have two sets of solutions. We should have it as a plus or minus here, since we'll have two sets of solutions, plus or minus. Therefore, have x plus 3 is equal to, what is the square root of 1? That is given as 1. Hence, we'll have plus or minus 1. Then we have to transfer 3 to that side. We'll have it as x is equal to negative plus or minus positive 1. And we'll have it as x is equal to negative 3 plus 1. That is given as negative 2, or x is equal to negative 3 minus 1, which is equal to negative 4. So these are the solutions using what we call as the completing square method. And what if we have this case as well? And let's see how we can have to understand that one up. Let's say if we can have something about 2m squared, and let's say minus 8m, and which is something about, let's say, 20. So how do you think we should have to solve for this using the completing square method, if that is the case? So make sure that this is a quadratic expression. Make sure that this has to be expressed in the form of the quadratic actual equation. Therefore, 20 has to be brought this side. So have it as 2m squared minus 8m minus 20 is equal to 0. And also from there, we should have to divide everything by 2, since value of a has to be equal to 0, actually has to be equal to 1. So to eliminate the value of a, which is other than 1, we have to divide everything by that particular value. So therefore we'll have it as m squared minus 4m minus 10 is equal to 0. Let's say if it could be, let's say, something about 9 over 2, you don't need to express this in a decimal form, because you may end up being confused with a decimal number. But if you know how to handle the decimal numbers, it is okay with you. And from there we'll have to transfer 10 towards that side. That will be given as m squared minus 4m is equal, should be 10. Then as you can see, we need to introduce the missing value here, which is c, by the principle of completing the square. We'll have c which is missing, and also c that side. Now, what is a? A is given as 1, and the b is given as -4, and the c is what we are looking for. And I try to have that and be able to solve for m using that method. And there's something you need to understand. B squared minus 4ac is equal to 0. This is the discriminant being given as 0 if it is a perfect square. But now, what happens if we are to solve for c, and if the value of a is 1? So in this case, this is the same as b squared minus 4c is equal to 0. And this is the same as -4c is equal to -b squared. And this negative will go have it as 4c is given as b squared. And in this case, c is given as b squared over 4. And now this is the same as you can see, this 4 is a perfect square. It can be expressed as b squared over 2 to the power 2, which is the same as b over 2 over to the power 2. Now c is given as b over 2 over to the power 2. And basically, this is the formula for the discriminant. And whenever the value of a is 1, and when we are solving for c. So basically, you see this formula being commonly used actually in all cases when we are solving the quadratic equations using what we call as the completing square method. So that's what happens. And also try to solve the following using the completing square method, and appreciate how we can have it. Let's say if we can have something about x squared and minus 4x minus 21 is equal to 0. And let's say x squared plus 3x minus 11 is equal to 0. And let's say n squared minus 14n plus, let's say, 2 is equal to 0. And also see, let's say if we can have something about, let's say if we have 5x squared minus 10x, let's say, is equal to -4. And what if, let's say, if we have 1 over 2x plus 1 is equal to, let's say, 2 over 2x minus 1, which is should be -5 rather here, -5. So how do you think you can solve for those? Using the fact that should be computing square method. And let's say if we can have 5 over 2x squared and minus 7 over 2x plus 1, which is equal to 0. Let's see that one. Let's say if we have 2 minus 3x, that which is equal to -4 over x. So try to solve those using comprehending square method. And finally, we also have another method that is being used to solve the quadratic equations. We call it as the quadratic formula. Let's say if we have the quadratic equation, the general form of x squared plus bx plus c is equal to 0. Upon making x as the subject, we have it as x squared, x is equal to -b plus or minus square root of b squared minus 4ac divided by 2a. So in case you may need of knowing how we arrived at having x as the subject formula, just have to check my video playlist, you come across all these things. I may also post the link in the comment section below, where you should have to look at how the analysis is done to make X as the subject there. So keep that in mind. So how do you think this formula is used? You know, B, A as well as the C are obtained from the given quadratic actual equation upon being expressed in the general form. And if the equation it is of any other variable other than x, we have to have that particular variable at the beginning, not x. So take note of that one. And let's say if you can have something about, let's say we have x squared. Let's say we have x squared and minus x is equal to, let's say, positive 6. So we should have to solve for this using the quadratic formula. So in this case, we should have to express it in the general form. We have it as x squared minus x is equal to 0. What is A? We have it as 1. What is B? We have it as negative 1. And C is given as negative 6. So this method does not necessarily require that the A should be given as a positive 1. We can have it as any other value. So quadratic formula is given as negative b plus or minus square root of b squared minus 4ac overall divided by 2a. Now for this case, we have it as what is b, that is negative 1. In terms of this negative, we have it as a positive 1 plus or minus square root of what is b. Now have negative 1 to the power 2 minus 4. What is a? 1. And what is c? Negative 6 divided by 2a. And what is that? Of which we have it as, you know, x is equal to 1 plus or minus square root of what is b to actually negative 1 to the power 2, that is 1. And we have plus 20 should be 4 divided by 2. So in this case we have plus or minus square root of 25 divided by 2. What is the square root of 25? That is given as 5. Then we can have that one as, you know, x is equal to 1 plus, actually 1 plus or minus 5 divided by 2. Now this is the same as having 1 plus 5 divided by 2, that is, you know, 6 divided by 2, that is given as 3. Or x is equal to 1 minus 5 divided by 2, which is the same as negative 2. So these are the solutions using the quadratic equation, to below the quadratic formula. And also we can have something about, let's say, what if we have 2x and plus x, which is equal to, let's say, 12. So make sure that the quadratic equation is in the general form of x squared plus bx plus c is equal to 0 in order for you to determine a, b as well as the c. And also try to solve the following using the quadratic formula. So let's say x squared plus 12x and plus 36 is equal to 0. Let's say 5x squared minus 10x and plus 4 is equal to 0. And what if we have, let's say, 3x squared and let's say is equal to, you know, should be about negative x, let's say, plus 10. So try to solve this using the quadratic actually formula. And also, what if we have something about this? Let's say if we have, let's say if we can have something about, let's say, m squared minus 12m minus 5 is equal to 0. How should you have that one? Let's say n squared is equal to, let's say, negative 6n and say plus half n. So how should you have this using the quadratic actually formula? And let us see how we can find or determine the quadratic equation given the roots. Let's say we have the roots of the quadratic equation given as a root 1 being given as n, and the root 2 is given as n. So we can only determine the quadratic equation given roots in form of ax squared plus bx plus c is equal to 0, whereby in all cases, if the only roots are given, value of a is always 1, and the value of b is given as using the formula root 1 plus root 2, and the value of c is given as using the formula root 1 times root 2. So that's how we should have it. Let's say if we have x is equal to 2 and x is equal to, let's say, -1. What is the quadratic equation corresponding to these roots? Now in this case, we have it as root 1 is given as 2, root 2 is given as -1. So using the formula, we know that the a is given as 1 since the only roots have been given, and the b is given as negative root 1 plus root 2, and the c is given as using the formula negative, so should be using the formula root 1 times root 2. Now let's try to determine those. B is given as negative, positive 2, -1, that is given as a positive 1 times negative, we have -1, and the c is given as 2 times -1, that is -2. Then we just have to simply substitute into this. That will be given as x squared. What is b? We have it as -1, that is negative x, and negative, what is the c? We have it as -2 is equal to 0. Now this is the quadratic equation given those roots. What if we have, let's say, m is equal to half, let's say m is equal to, let's say, 5. Principle remains the same. Since the only roots are being given, automatically a is given as 1 and the b is given as negative half plus 5, and the c is given as half times 5. So try to have that in the substitute, and since the roots are of m, it means it is the quadratic equation of m. So try to have and substitute this in that. So that's how we should have that one. And let's say if we have the following roots, so try to determine the quadratic equation given the following roots. Let's say if we have the first root, -1, and positive 2, -1, 2, let's say -3/4, and let's say 2/3. So try to have that one. And what if, let's say, if we have negative square root of 2/5, and let's say 1/5, how should we have that one? And what if, let's say, if we have -11/5, and the square of, let's say, 6/, let's say, 7. So try to have that one. So then the next video will be about how discriminant is used to determine the nature of the roots of the given quadratic equation. Thank you.